Okay, real quick, we're going to look at the derivatives of some trig functions. First trig function we want to look at is y equals sine of x. Okay, if we want to take the derivative of y equals sine of x, what you have to consider is thinking about what everything means. First off, you're thinking about your slopes. So I'm just going to plot my slopes against what I have here as my curve. And if I plot my slopes against what I have in my curve, but think about this. Right here I have a slope of 0. So for my derivative, I'll put a 0 right there. Okay? Here I also have a slope of 0. Here I also have a slope of 0. Here I also have a slope of 0. So I've put purple dots there everywhere that I have a slope of 0. Now, let's think about the steepest places that we have slopes. Okay, this is where your slope's the steepest. It's positive, it gets steeper, and then it becomes less and less positive. If I put a tangent line up to it, that's going to be at 1. So I'm going to give a slope of 1 right here. And I'm also going to have a slope of 1 right here. Now, I'm also steep right here, but I'm just steep in a negative direction. So I'm going to say that this has a slope of negative 1. Likewise, this would have a slope of negative 1. So, let's see, we've got negative slopes from here to here. And then when we get here, it's still negative slopes, but they become less and less steep, so they get closer and closer to a slope of 0 here. So we're going to move up to here. All right, now we start having positive slopes from here to here. They're gradually getting steeper and steeper, so they're gradually increasing in rate. And then they start decreasing in rate. And so forth. So what winds up happening here is that for sine of x, the derivative is actually cosine of x. Now there is a way to prove this with the sum and difference identities of sine and cosine, but for right now, for the purposes of what we're doing here, the derivative of y equals sine of x is cosine of x. Now let's go with the graph of y equals cosine x as we have it up here now, and let's think about what its derivative is. Well, its derivative, you might think, well, it's going to be sine x. Well, let's see if that's true or not. I'm going to graph this one in brown. So right here I would have a slope of 0. All right. Right here I have a slope of 0. Right here I have a slope of 0. And right here I have a slope of 0. So it's starting to look like it's going to match up with the sine graph. But let's see what happens here. Okay, my purple graph right here, I'm decreasing right here, right? So my slopes are negative, so I should be plotting negative points right here. This is steep at negative 1. But this doesn't match up here. And also I'm decreasing, so my slopes are negative, so they should be below the below the x-axis. Now I start having positive slopes from here to here. Again, the steepest value being right here. I'm still positive, but now I'm decreasing in value. Okay, and when I get to right here, my graph starts having negative slopes, so I get negative values. Again, here is where I would be at my steepest. Coming back up here, sorry, I pop up here. Coming back to here, I would have still got negative slopes until I come up to here. So what winds up happening is this brown graph is not the orange graph, but it rotates it about the x-axis, so it's actually the negative of that. So y prime is not the sine of x, but y prime is the negative sine of x. So the derivative of sine of x is cosine of x. The derivative of cosine of x is not sine of x, but it's the negative of sine of x. Now, let's consider tangent. So, for the derivative of tangent of x, I'm going to take this and turn it into a quotient, because we learned quotient rule last time, right? So I'm going to say that this is the quotient of sine x to cosine x. All right, well, without me doing my dance again, let's talk about low d high minus high d low, go down under and square the low. So it's low. All right, d high, again, we said the derivative of sine of x is cosine of x. All right, minus low d high minus high, sine of x. All right, d low, the derivative of cosine of x, negative sine of x. All over, go down under square the low, so cosine squared x here. Okay, now let's simplify it. Cosine of x times cosine of x is cosine squared x. Negative sine of x times negative sine of x is plus sine squared x. And then we have it over cosine squared x. Now this is still not simplified, and please, please don't make me cry and cancel those two cosine squares out together, because that's canceling part of a binomial out with a monomial. But what we can do is we can take this is a Pythagorean identity. If you have the cosine squared x plus sine squared of x, it's 1. So we get y prime is equal to 1 over cosine squared x, which happens to be secant squared x. So the derivative of tangent is secant squared x. Now, what I would like for you to do for homework, outside of what I've already assigned, is I want you to derive, using the quotient rule, the derivative of cotangent of x, the derivative of secant of x, and the derivative of cosecant of x. So go with those videos, go with those, see how you do on those, and you also have your homework from WebWork to do. Bye.